Today we're going to be learning about electron configuration. So what is electron configuration? Electron configuration is a numeric representation of its electron orbitals. We use this to describe the location of an element. On the periodic table we have 4 different blocks. We have the S block, the D block, the P block, and the F block. In the S block, you can hold 2 electrons in each orbital. Block you can hold 10 electrons. In the P block you can hold 6, and in the F block you can hold 14 electrons in each orbital.
Going vertically is your groups, so all of these are your groups, and then going horizontally is your periods. For your first 2 groups going down, that is part of your S block. Your transition metals is your D block. Part of your metals and metalloids, halogens, noble gases, is your P block. And the last 2 rows, the least reactive metals, is your F block. To understand electron configuration, you're going to go from left to right. Follow the atomic number, starting with hydrogen at 1, and then helium is across the chart, so you may want to move it to next to hydrogen so that you won't get confused and make it part of your P block. You can see here the atomic number is at the very top of the element. So 1 being hydrogen, 2 helium, then 3 lithium, and then going across, so 4, and then 5, you can see it's already part of your P block.
So I'm going to show you the electron configuration for hydrogen. So hydrogen is going to start off in the S block on the period number 1. So it's going to be 1s1. So we're going to write that down. It'll be 1s1. And just to go into further detail, that's because it's in the first period. So you're going to go across, and hydrogen is obviously the first one, so it would be 1, and then you're in the block S, and then it's going to be the first element. So there's the electron configuration for hydrogen.
So we're going to take it a bit top notch and go with carbon, atomic number 6.
The amount of electrons in an element should equal the sum of the numbers at the top, which is like the exponential of the block. So basically, just to put that into perspective, carbon is going to be, so you're going to go 1s2 because you're completing the first row. You're going to go over here to 2s2.
Like I said, you follow the order of the atomic numbers. So hydrogen being 1, 2, 3, 4. What's next is 5, starting at boron.
So you're going to go 2p2 because here's carbon. It's 2p1, 2p2. So then you're going to end here. So now we're going to write the electron configuration for carbon down. It'll be 1s2 because you're filling up the first row of your elements. And then you're going to go over to 2s2 and then
finishing your second row.
Then you're going to move over here to 2p1, 2. So it's going to be 2p2. So what I mean by the amount of electrons in an element should equal the sum of the numbers at the top, we're talking about these numbers up here. So you have 2, 4, 6. So it should equal 6 electrons.
If you are confused about writing your electron configuration right or wrong, you just add these numbers on the top, and that should give you your amount of electrons.
Alright, so chlorine.
Atomic number 17.
So we're going to start off on the S block. We're going to go 1s2 because we filled up that first level. Then we're going to go over to 2s2.
And then you go straight across following the atomic number in order.
So we're going to go 2p1, 2, 3, 4, 5, 6.
Remember, chlorine is 17, so you still have more to go after neon.
So we're going to slide all the way down here to 3s2 because we finished that block, or that row. And then now we're going to slide all the way over to 3p, 1, 2, 3, 4, 5. So it's going to be 3p5. Alright, and that's our electron configuration for chlorine. Alright, and this will conclude your lesson on electron configuration. We hope you learned something, and
Thank you for watching.